Welcome to the July workshop for the Azure Fundamentals. This is for the AZ 900 certificate, and this is just a workshop to kind of prepare us for that exam. And at the end of this, you will get a 50% off coupon. I just want to introduce myself and Rena while she's here. My name is Will Calhoun. I am one of the instructors for the part-time accelerated program. I am also the lead for the Azure, course for Coding Dojo. And so I will be here for the morning section, so just 9 to lunchtime. And then Rena will be taking over for the afternoon, and she's going to walk through some really fun things. And Rena, if you want to go ahead and introduce yourself, feel free.
Yeah, thank you, Will. Hi, everyone. I'm Rena. I'm also one of the part-time instructor working with Coding Dojo from almost 1 year. So you will be with Will for first half and you'll be with me for second half for some fun activities and probably some fun, testing. So I think all over to you, Will.
Yeah, appreciate it. Cool. So this morning, we're going to go through what it's going to look like, but this morning is going to be a little bit more intensive when it comes to information. So I'm going to be teaching a little bit more in the afternoons where we're going to really get hands-on, and that's where Rena's going to come in, and we're going to get really hands-on into diving into material. You guys are going to kind of dive into the material yourself, get familiar with the Microsoft platform, and actually create a cheat sheet. So that way, as you guys are preparing for the exam, you have some extra tools that you can create. So with that, just want to say welcome. We've been doing this for the last 6-7 months. Quite a few people have gotten certified. This is a thing that is ever changing. And so I just want to say welcome. Thank you for taking some time out and joining us today. In chat, if you could, can you put when you graduated and maybe what program you graduated from? Are you from the full-time? Are you from the part-time? When did you graduate? And, maybe your favorite language to write in. That would be awesome. Somebody had a question, what's the setup needed, VS Code and Azure membership? For right now, you don't need to set up anything. Eventually, you can set up a Microsoft account for Azure, but for this workshop, you actually don't need to do that. That's okay. We are going to just kind of walk through some stuff where you don't have to set anything up, and we won't be doing anything in VS Code. So I've got full stack Python, June, favorite language, JavaScript, okay. Online, May 28th, Python, full-time, April, okay. This week, way to go, part-time online, Python and MERN. Oh, there's lots. Java, lots of Java. C#, okay, wonderful. C# is one of my favorites. It's like this beautiful hybrid. If you've never looked at C#, it's this beautiful hybrid of Java and Python, which is really, really awesome. Cool. So let's go ahead and jump in, get started. Just a couple ground rules here. We have 4 real main things. First one is just teamwork makes the dream work. We are going to be working in groups. We're going to be working together to discover and learn. And so we just ask that teamwork is really kind of at the forefront of our mind. If you know all the answers, that doesn't necessarily help anybody, right? And so, or kind of dominating and always being the one. So we would just say, like, teamwork makes the dream work. Help your fellow students, help your fellow cohort mates with just understanding this material as you guys are diving in to that as well. And kind of going into that, it's maybe humility. You don't get extra points or anything if somebody asks a question and you say, that's a stupid question. We just ask that you don't do anything like that because people are trying, right? We're all trying to learn. We're all trying to grow, all trying to become better developers. That's why we're here. And so just humility is huge with that. And then third is strength through struggle. Now, as you guys came out of Coding Dojo, you guys are fully aware of strength through struggle, right? We talk about that a lot. And if you've never learned anything about the cloud, initially there might be a little bit of struggle, right? Understanding the concepts. That's what our whole goal is here today. Just understanding concepts. But if you can push through that, I promise you that this will be something that will help you. Even if you don't want to do anything in cloud computing, this will be something that will help you in the long run with understanding and learning just different aspects of development. And the last one would be respect. That is just for the group. If somebody's talking, try to keep muted. If there's something in the background, put yourself on mute. If somebody's talking, kind of let them finish their point, and then, feel free to kind of chime in, but just let people kind of have their allotted space. With that being said, if you guys are, I personally, like I said, love a group that it's a conversation. It's not me just talking 24/7, because that will get exhausting and tiring. So feel free to come off mute, ask questions, put it in the chat. Right. If most every section, I will say like, hey, are there any questions, anything we can walk through here? So I'll give you time to kind of unmute. And if you do have a question, just put it in chat, and then at each section, I'll also read through the chat if there's a question and try to answer it to the best of my ability. Cool. So this is a little bit of housekeeping. Today's obviously July 7th. We're going to be doing this from 9 to 4:30 is kind of our anticipated time. Now, it might be a little bit earlier. It might be about more 4 o'clock, which is fine. At the end of the day, I think having 8 hours together is quite long. And we've just noticed that, if we can compact it a little bit more, it kind of helps with learning. So we're going to do from 9 to 4:30. And the format is going to be discussions plus exercises. So like I was saying earlier, this morning is a little bit more discussion heavy. We're going to be, discussion and kind of conversation heavy, where we're going to talk about why would a company go to the cloud? What are some benefits to the cloud? From a company perspective, understanding why is the cloud a thing? Because although we are developers, if we want to have the right and kind of way to speak into a company's operational, procedures, in the sense of, do we go to the cloud or do we not? We don't want to just bring, well, here's the technical reason on why we could go to the cloud. We need to kind of broaden that a little bit to where not only is technically here's why the cloud is great, but also from a business perspective. So we're trying to have a good rounded out understanding of what the cloud is. And so that'll be, again, heavy in the morning. In the afternoon, it's going to be a lot of exercises, and then diving in and talking about the exercises. So that's what we will be doing. One thing I do just want to point out is this workshop obviously is free. And there's not ever going to be like a limit of how many people can come. You can only attend one of these lectures, in the sense of, if you come through the entire AZ 900 and the next month you try to go through the entire AZ 900, you can't do that. But, if something happens and you have to hop out early and you're like, oh, I have this really big issue, I just need to leave, that's totally fine. You just have to let me know, and then you can, retake the course if you want. But if you can stay throughout the entire afternoon, once that is done, you will qualify for a 50% off voucher. Now, this voucher is going to go, you can use it towards your AZ 900 certification exam. You can use it towards any sort of exams. We're going to talk about all the different ones that they have now. But basically, it's a 50% off voucher, which its value is about $50. The exam is $99. And so it'll be a $50 savings. So right after the workshop, we'll have kind of your information, and you will qualify for that. Here's the agenda of what we're going to talk about just this morning. Like I said, pretty heavy in the morning from 9 to 10:15. This is also including like our intro. We're going to talk about Azure, and then what is the cloud. We're really going to dive into that. Then we're going to have a break. After our break, we're going to have a group activity. We're going to be put in a group. You're going to have to dive and learn a little bit of information. And then just with your group, create a company, which is really fun. It's one of my favorite activities. We're going to come together, present our findings and our final thoughts. And then we're going to close up for lunch. And then at 1 o'clock, we will start back. This is all Pacific time as well, the PDT. So perfect. Here is all the resources that we have for AZ 900. Now, this morning, like I said, we're going to be talking about cloud concepts, some of the core Azure services. There are a few things that we might talk about in security and governance. It's going to be more the Azure services will be more of the afternoon, but here are the different pathways we wanted to put this. And at the end, you will, tomorrow, you'll also get this entire slide deck. So you'll have all of these different pieces. But this morning, we're going to be talking about really focusing on these cloud concepts part. And then afternoon, we're going to be really focusing on the core Azure services. The reason for that is there's a breakdown for what is actually covered in the exam. And these are the two most important, biggest chunks. So we really want to take the time to do that. Any questions so far about where we're at before we kind of move on to the different opportunities you can have from a certification standpoint?
Hey, really quick, the pronunciation of it is Azure.
Azure. Yeah.
Okay, thank you.
Yeah, of course. Cool. So Azure, this is for AZ900. This is the base certification. There is a ton of different certifications that Microsoft has. Azure is their cloud. We're going to talk, I have a slide here about like what actually is Azure. But there's a lot of opportunities for certifications within Microsoft. Now, these are great, great, great things to have on your resume, on your LinkedIn, different things for recruiters to see. And right now, currently for Coding Dojo, we offer three, actually technically four workshops. We just included another one, but here are the three main ones. We have our AZ900, which is what we're doing today. This is for really web development. Then we also have an AI 900. This is the Azure Artificial Intelligence Fundamentals. That is an entire certification as well. And then we do the Azure Data Fundamentals, which is our DP 900. We offer these once a month, each week. So next week, or each month, sorry. And so, each month you will have one AZ 900, one AI 900, and one DP 900. Now, I would say that you can absolutely join as many as you want each month. But my encouragement would be focus on one, give it 2 weeks. And then if you want to get all three, you do get a coupon for each one, right? So you will have 3 coupons you can't stack coupons together, unfortunately, but you will have 3 coupons. But I would say give yourself, like if you wanted to do AZ900, take this cert today, or, take this workshop today, give yourself 2 weeks, set up the exam, take it, and then go to the most, the DP 900s at the end of this month, then maybe take that one. So I wouldn't say, I wouldn't encourage, I absolutely would not encourage you to take AZ900, then next week take AI, then next week take DP, because you won't have time to actually study it. And then you will forget it. And then you're going to have to go and relearn it all again. And you've just wasted 24 hours of your life. So I would definitely just suggest, give yourself 2 weeks after the workshop, study it, and challenge yourself to, get certified after 2 weeks, and then take the next workshop. Somebody asked, is it written theory or programming exam? It is written theory. So it's not like a fill in the blank sort of thing, but it is a multiple choice based off of Azure services, Azure kind of fundamentals, cloud fundamentals, which we'll go through, and you'll see we have some practice exams that we'll go through at the end of the day, and you'll have a really good understanding of what the exam is really like. Now, these are the 3 base ones, right? The kind of your base of the web development and data science, but they also offer other ones, right? So the next step after AZ900 might be this Azure Developer Associate. Now, again, if you take maybe DP 900, the workshop, and you're not really interested in data, but you take the workshop anyway, you'll learn something great. But then you can also use that 50% off coupon for maybe this Azure Developer Associate. Now, this one's a little bit more intense. So the study time might be a little bit longer, but there are tons of different opportunities for web development, for web application through Azure, and just really getting certified and have a better understanding of what the cloud is, how the cloud works, and different aspects of the cloud, specifically Microsoft's cloud, which is this Microsoft Azure. Now, we also have some circles here that kind of just say, if you want to go into web development, here are some that are associated with web development that maybe you would look into doing, which would be this Azure Developer Associate, and then this Azure Data Scientist Associate. Now, if you are interested more in the data science, there's quite a few options there. We launched this Data Analyst Associate. So we do now have a workshop starting this month on this DA 100. And then if cybersecurity, the security engineer one's a great one, and the DevOps would be this Azure Administrative Associate. So all that to say is there are quite a few certifications that you can do. Again, each certification will just boost your resume, boost your validity to, kind of recruiters and to companies as well. Cool. So our point today is that we're going to learn about the cloud, and you're going to be able to demystify it. Now, there's a lot of kind of speculation about the cloud, and what is the cloud, and what does the cloud mean, and how does it work, and is it just in the air? Just, there was a funny movie that talks about like the cloud. And it's like, well, the cloud's just everywhere, right? It just goes somewhere. So we're going to be able to demystify it and actually look, well, what actually is the cloud? And then once you do get a certification, once you do pass the exam, you can put that on LinkedIn. That will boost your, like how many people are viewing your profile. That happens all the time, right? Anytime a student boosts and says, you know, oh, I just passed this, we always ask and we always see that multiple people will view their profile. You know, recruiters all around will see that now you're certified and stuff, and it will become very, very popular. Now, one thing I do want to point out is this source here that just kind of shows, it says you'll have an increased potential in the market. Now, here is just a year-over-year demand for cloud skills and starter jobs. And as you can see, since 2016, it has blown up. Here we've got this gray is AWS. This gray is AWS, which is Amazon Web Services. This orange is Azure, which is Microsoft. They're both just clouds, right? And then blue is just the general cloud. But as you can see, it is continuously climbing because cloud is basically in everything that we do. As web developers, you will have some sort of thing in the cloud, and we're going to understand why here in a bit. But I really just want to point this out. This is something that will impact your career and your ability to find a job quickly out of the boot camp. Having this on your resume will set you apart from people. There is a 58%. It has, so year-over-year growth has been 58% annually. So each year it goes by 58% for Azure. And then overall, it's a 30%. This is in starter jobs. And so this stuff is really, really, really important. So I'm glad that we're going through it here just to show you kind of what is going on there. Cool. Here's just kind of the learning path for the Azure fundamentals. For the AZ900, here are the big things that you're going to need. This comes straight from the Microsoft website. So the skills required for the certification are to be cloud concepts, which we're really going to hit today, and this core Azure services, which again, we're going to hit this afternoon. The reason we don't hit necessarily the security, privacy, compliance, and trust and the Azure pricing and support is this is a little bit more of just plug and play memorization. You know, how much does a specific Azure thing cost? And so that's why we don't go through it in the workshop. Our goal is really to break down the kind of muddier concepts and the bigger concepts. And you guys are all adults, so just memorizing and kind of studying for a test. This Azure pricing and security portion, those are more just, like I said, memorization. So that's why we don't necessarily really hit on them. We'll hit on security and privacy a little bit this afternoon or this morning, but this Azure pricing and support is really just more plug and play. So that's why we will focus on these cloud concepts, core Azure services. And then after that, you will be ready for the exam. And then continue on. And if you want more exams, you can absolutely do that. Here's a format for how AZ kind of 900 is set up. This is for the exam itself. Oops, sorry. Really, the biggest hitter is cloud concepts. And it does have identity, governance, privacy, and compliance features as 25%, but that has actually changed. It is a little bit less than that. And it has shifted to this core Azure services. That's why we have it here, but on the actual website, it still has, you know, this posted here. But these are the different little pieces. Now, it's not that every single question is going to be, you know, specifically from general security and network security features, but it might have a little piece. Now, in order to pass, I believe you do need a 75% or 70%, sorry. And so as long as you can get a 70%, then you've passed it. There is no, you know, different belt. You know how we had different belts. There's nothing like that. It's either pass or a fail as well. So here's the format for the actual exam. And again, this just comes straight from the Microsoft platform as well. Cool. Any questions on Microsoft, the platform, anything like that? I do want to show you guys the platform while we do this. There is this platform here, and this is what you guys will have plenty of time today to kind of walk through this stuff and walk through the actual platform. This is the Microsoft platform. This is where all of the material for the actual exam will come from. If it's not here, then it's not going to be on the exam. And here is the different things that you can do. There's some really great learning paths. So you can do something like this, right? Where we describe core concepts. There's 6 parts, describe core concepts, and there's videos and different aspects that you can walk through, but each one will have this modules in this learning path. So again, there are 6 paths and then there's modules per path. So looks a lot like the Coding Dojo platform. And all you do is you kind of just click it, and then you'll see all the different pieces. It gives a time frame of about like roughly how long it's going to take to read or to do anything like that. And you click on it and it gives you some sort of information. Sometimes there's videos, other times it's reading, but there's quite a few things. This is awesome. This is a great platform for you to go through, and we would encourage you to continue to go through this. And throughout the platform, they also have knowledge checks. So it's not like you're just reading and then mindlessly like forgetting everything. There are things that are going to check for knowledge to see what have you learned, what have you really gotten into, and what are you understanding, as well as exercises. So there is like an exercise. So create a website hosted in Azure. And this will actually have you go into Azure, set up an account, and then create a website hosted in it. So you can kind of get familiar with how Azure works. So I would say the Microsoft Learn platform is an awesome tool that we will be spending a lot of time in today. And you guys later towards this morning, you will actually spend quite a bit of time in this section, actually, with this fundamental concepts and understanding different cloud services, along with this regions, availability zones, and region pairs section. So you guys will, that's what we're going to be doing in our exercise this afternoon. Any questions before we jump in? Now we're going to actually start jumping into the material. We've gotten through all of the kind of basic stuff.
When you explain that, like the cloud concepts, is this just for this program, or will this be something that is like interchangeable?
Yeah.
To all.
Yeah. So this is going to be great question. This is the general cloud, right? So whether it's AWS or Azure or Google Cloud, how the general cloud works and why a company, we're going to have an understanding from a very generic standpoint of why a company would move from what we call on-premise to the cloud. Great question. Perfect. Cool. So first off, does anybody know how the internet works? I know this sounds like a weird question, but from like a rough perspective, how does the internet work? How do we get internet? Anybody know? Does it come from satellites? Does it come from the sky? Service provider, magic, computers talking to each other, HTTP. Well, is it just like, is internet everywhere? So these are request response cycles, but how does how do we get connection from one to another? Anybody know? Networks. Yeah. This is one of my favorite photos out there, but this is how the internet, this is the infrastructure of the internet. There are cables in the ocean, and then obviously on land. There are cables everywhere around the world that allow us, and it's just cables, fiber optic cables that connect everywhere, right? You can see this connects from South America to Africa, and they're all interconnecting. And this is how data is traveling through these fiber optic networks that are actually in the ocean, on land, or under the ground. But this is how the internet works. It is crazy. This is how the internet works, right? It's just data traveling back and forth on fiber optic networks. And as you can tell, right, like there's some heavier areas, right, which actually makes sense. This is more like New York City to like the UK / Paris / kind of the EU. So it looks like, look at all these cables here connecting, because it goes back and forth a little bit more developed countries versus, a couple cables here and there that are traveling. So you can have, even just looking at this picture, a different understanding of, oh, maybe this is why internet in one area or one geographical location is a little bit worse than something in maybe like the EU or in New York City, right? Because this is how this all is working. These are cables and they are connected and they are talking to one another. And this is crucial for us understanding just kind of the cloud, right? So we know, okay, so we have these cables. And so what is the cloud? Well, the cloud actually refers to a software and services that run on the internet instead of locally on your computer. And so right now on your computer, you have hardware and you might be connected to the internet and you can run stuff locally. Now we've talked about, or if you guys are in, when you were in your different cohorts in your different languages, let's say you were in Python, because I think everybody took Python mostly. When you spun up, like if you had Django and you spun up a server and you went to localhost 8000, that is running locally on your computer's how this is running, right? And then that's why if you were to run it on the internet, it would look on your computer. Like if you typed in localhost 8000, it sent a request to your local computer. But if you gave your friend localhost 8000, that wouldn't actually connect, right? I don't know if you guys made that mistake. That always happens. I did when I first started developing, like, look at what I created. And it was on localhost 8000. People like, this actually is nothing, right? Because it was locally on my computer. But this, the cloud is a way that we can actually run software and services on the internet, right? And so we can put it to a server somewhere. And so instead of it running on my computer, it can actually run on a server anywhere that is accessible to others. How many of you, did anybody get a black belt whenever you were studying languages? Anybody get a black belt? Yeah. So when you got a black belt, okay, Trey. But when you got a black belt, what a black belt was basically a little bit more advanced querying and understanding of the language, but then you also had to deploy. And what deployment did, and we're going to go through kind of the process a little bit later on today, but what deployment did is you put it on a server on AWS, right? You put it on an AWS server. So that way your instructor or your friends or people could go to that instance, go to that IP address, and then you could actually see your application running. And so the cloud really is just servers in an area that allows for software and services to run on the internet instead of just locally on your computer. So what is Azure? Azure is just a cloud computing service created by Microsoft. So it's Microsoft's version of the cloud, and it's used for building, testing, deploying, and managing applications and services through Microsoft managed data centers. So Azure is Microsoft's cloud. AWS is Amazon's. Google Cloud is obviously Google's cloud. And so Azure is going to be the different services that Microsoft's cloud provides. So Azure is the cloud for Microsoft. And each cloud does operate differently. That's one thing I do want to point out, is each cloud does operate differently in the sense of there are different services and built-in functions that each cloud might offer. And so Azure will be separate than AWS for instances on how it handles something specific. So that is why you go and you get certified in AZ900 or AWS. But Azure, from a very general perspective, is just a cloud computing service created by Microsoft that is Microsoft's cloud, and it is becoming wildly popular. Right now, they have, Microsoft touts that they have the most servers anywhere in the world, and there is a increase in people wanting Microsoft Azure. Right? AWS kind of had the biggest market cap, and now Microsoft is slowly coming in as a close second. Somebody asked, is Microsoft's OneDrive also hosted through Azure? Absolutely. I would say anything Microsoft, like GitHub would be Azure, LinkedIn, Azure, everything is going to be hosted on Microsoft's cloud. Cool. So we've talked about the cloud, and we've talked about how it's servers, right? Servers connecting via the internet. So let's pretend that we are new developers, right? And we get to a company and they say, hey, we currently have servers of our own, or, hey, we're working at a startup. You're a new developer working at a startup. We're trying to decide, should we buy our own servers, maintain our own servers locally, or should we use the cloud? And so there's two kind of options we have in cloud computing. One is called on-premise. On-premise is the company houses all servers locally. Everything is done in-house. That means your company buys servers, buys server racks, sets up servers, sets up the network, sets up the operating system, sets up everything. You are fully in control. You do everything. That is what we call on-premise. The other one would be the cloud. So what it would do is, instead of your company buying all the servers, instead of your company buying everything in-house, all you do is you use a service like Azure, like AWS, that you use it, you kind of pay for a service that houses and cares for all the servers, and you just pay for what you need, right? You pay for somebody else to handle it. It's kind of like renting a house versus owning a house, right? Renting a house does have some benefits. If something breaks, if something goes down, it's not on you. You can just, tell the landlord, hey, I need you to go ahead and handle this. You can kind of think about it that way, versus on premise is like owning the house. Like, you are in charge of everything, no matter what happens. And I also put here this honorable mention. There is a hybrid option, and that we're going to explore that a little bit later on. But a hybrid option would be where you have some aspects of your company on the cloud, but yet you do have some aspects on premise. Maybe a bigger company like a Facebook might have an on premise, right, for specific things, and then use the cloud for other aspects. And so there is a hybrid option that I do want people to kind of have an understanding of. I will also say this: it is not uncommon for a company, a large company, I would say not a smaller company, but a large company, to use multiple clouds for multiple things. So maybe AWS has something really, really great for this one portion of your company, and Azure has something that really, really great for this one portion of your company. It is not unlikely, if a company is not, like a Microsoft or Amazon company, for, to use different clouds for different portions of your company. So that's just called cross-cloud computing. So if you're using multiple clouds, or you're using Google Cloud along with Azure, right? That is something that is an option as well. So we have on-premise, and then we have the actual cloud itself. Now, the cloud is wildly popular, as you can tell, and as you kind of understand. And there are what we call the big 6 benefits of the cloud. Here are going to be the things that you just should know. Here are the benefits of the cloud and what they are. That's high availability, scalability, elasticity, agility, geo-distribution, and disaster recovery. These are the big main things. Now, obviously, the cloud is this big network and web of different things, but these are going to be the big 6 of why the cloud is so popular, and why it is such a kind of an easy transition to the cloud versus, traditionally we were on premise. First one is high availability. So depending on kind of what service level that you agree to within your cloud, which we're going to talk about service levels here in a bit, but whichever one you do, it can provide continuous user experience with no apparent downtime, even when things go wrong. The idea behind this is Microsoft is so large, they have so many servers in so many places, that even if one goes down, they can transfer it to another one very quickly, to where maybe even your customer doesn't even see anything go wrong, right? So by having so many servers places, there's a chance that if something goes wrong with one, you can transfer it to another, versus let's say you had it in-house, right? It was on premise. If your servers go down, your servers go down until you get new ones, until you get the new ones set up, till you have all those different things, you're going to be down. But here with the cloud and these kind of big AWS, Azure, obviously, and then Google Cloud, even if things go wrong, they can transfer it, because just their reach is so large, they can transfer it somewhere else to where, you're up and running maybe in 5 minutes. So that is high availability. The next one is scalability. This one is my favorite, and it's important. But basically, what the cloud allows you to do is you can scale vertically and horizontally. Now, what does that mean? Well, when you're doing the cloud, right? When you have stuff put on the cloud, you are basically renting part of a server, right? And what we call a virtual machine. Now, if you did a black belt, you understand what that is. But from a very easy capacity, what you're doing is you're going on to Azure and you're saying, cool, I want to set up a virtual machine. And what it is it's like on a server somewhere for Azure, it creates what could emulate basically a computer, right? So in the same way that I'm on my computer now, I can go create a virtual machine. So virtually, I have this computer with an operating system. I can, create applications. I can do anything I want on that computer. And so what scalability does is, let's say we have an application that we're about to do, we're doing something in stocks, right? And now all of a sudden, all this data is given to us and I need to crunch through the data really, really quickly, right? I need to have some really high end calculations happen. Well, what I can do is I can actually increase my RAM or my CPUs on my virtual machine. Now, if you know anything about computers, you don't have to know a ton, but RAM is like your memory in the sense of how quickly things can work, right? So if you have maybe 4 GB of RAM, it might be a little bit slow compared to 8 GB of RAM on your computer. And then 16 is kind of like the ability for your computer to multitask and do multiple things at once, right? So if we're doing a bunch of calculations, by adding RAM, we can make our computer have the ability, right, to process even quicker. It's like shooting a little shot of adrenaline, and there was same thing with the CPUs. So you can actually make it quicker and be able to process that. Or you can scale horizontally. Now, what this is let's say you have a web application that 100 people are going to, and then now all of a sudden 500 people are coming. Scaling horizontally allowed you to actually take that virtual machine that you have set up, has your application, and eventually it gets to a point where so many people are trying to request it, it's starting to bog down, and people are having to wait their turn in order to get access to your application. What scaling horizontally will do is it'll actually allow you to take that virtual machine and copy and paste it, basically, to where now you have two. And so it can filter, now there's only 250 per machine. If you need to increase it even more, goes to 3. So you can scale and set up virtual machines, time and time again, to where, your customer actually doesn't see any sort of slowdown, but they can just quickly go to your application, and then it's, there's not too much traffic that's slowing it down. So that'd be scalability. Agility. So basically it allows you to deploy and configure cloud-based resources quickly as your app requirements change. So let's say you need to update your operating system, or you need to update, some aspect of your application. It's very quickly can you log in and change different aspects of your application, right? Or add in resources. Let's say, kind of like what we just talked about with adding RAM. Let's say you really quickly needed to add one different data type or one different sort of like database. You could just quickly add in and quickly do it because of the agility of the cloud. It's very easy to do that versus having to go in and actually, versus having to go in and add more memory on your server, add certain things to your server. That'd be agility. Next one is geo distribution. You can actually pick where in the globe that you want to set up your servers. So we looked at that, right? We looked at how the internet works and how everything's on cables, right? If my customer base is in Australia, it doesn't make sense for me to set up my server in, let's say, Germany, right? Or, Northern Ireland, if there's one there, because it has to travel every time somebody in Australia hits my application and my server is actually in Northern Ireland. It has to travel all the way over there to get it, and then travel all the way back, which, might actually slow down. I don't know if you've ever been to a website on another country, right? But it has to slow down, and it'll take a little bit longer for that data to travel back and forth. What geo distribution does is it allows you to put your server wherever you want to be. So if you were on premise, then you'd have to have, right, an entire location in Australia. But here it's like, oh, I can be in New York, although my customer base is Australia. I can put it on a cloud in Australia, and then it has the quickest kind of time back and forth and the best experience for my customer. And the last one is disaster recovery. So let's say there's something happens. You can, if you're on premise and something happens to your data, or somebody hacks or does something different, right? Maybe not hacks, but your database breaks or your server goes down and it fries, or there's a fire, right? Then you're done, right? Everything you have was on those servers and you're done. But what the cloud allows you to do is you can set up backup services. You can set up data replication. That way, if one server goes down, let's say there's a fire one night and one server goes down, or one kind of entire data center goes down, if you've set up these backup services and data replication, all your stuff is somewhere totally different to where now you still have access to all that information, right? So it's like, I didn't lose out on anything, even if there's a disaster or like a natural disaster, right? Let's say that, there's a flood wherever and the servers get ruined. Well, if you have this backup because of the cloud, you can confidently say that's okay. Like, I have data replication. I am not going to lose everything my company has, which is a big deal if you're somebody like Facebook, right? The money that Facebook makes is off of advertising, off of information of their users. It's not, on anything that Facebook creates, right? It's off the information of their users. So if you lose that data because of a flood, well, your entire business model goes down. So the disaster recovery is a big piece of the cloud. Are there any questions on the big six? Any sort of things that, I could kind of walk through a little bit more?
Did you go over elasticity, Will?
Yes, I did. Oh, no, I didn't. My bad. I think I went straight to agility. Yeah, so elasticity is great. Sorry, thank you for that, Alex. Is you can actually configure. So we talked about scalability, right? To where we say, okay, I can scale either vertically or horizontally. But what elasticity does is I can actually set it up to say, hey, I want to auto scale, right? So if my traffic's increasing, once it hits this threshold, right? We talked about the 100 to 500. Say, okay, if it's at 100, let's say we want to have one virtual machine. Let's say once it gets to 200, go ahead and I want you to scale horizontally, create another one, and then start sending people there. So elasticity is great because what you can do is you can actually change what you need varying. Let's say at 1 a.m., you're probably not going to have as much traffic as like at 3 in the afternoon, right? 3 p.m. So what it will do is you can actually auto scale to say, well, I don't want to use as much resources at 1 a.m. because I'm not going to have that much traffic. So elasticity allows you to kind of change what you're using at different times versus, let's say you have a server, whether it's 1 a.m. or 3 p.m. you're using and you're having to maintain that specific server versus elasticity allows you to kind of change your application to what is best for you because, and we're going to go through this in the next slide, the cloud is what we call a consumption-based model. So you pay for what you use and you don't pay for what you don't use. And if you don't need to use it, you don't have to pay for it. Thanks, Alex, for that. Any other questions? I don't know how I skipped that. My bad. Oh, so you might be thinking, all right, so I get like help me understand. I can have data recovery. I can put it anywhere I want in the world. I can scale. I can add more computer power. I can add more computers, basically. I can set it to auto scaling. This must be way more expensive, right? Because I'm doing so many things. But that's where the cloud comes in. And this is why the cloud is really important. This is why the cloud is really kind of becoming the forefront of how computing is happening and how applications are running in the world today. Because the cloud runs off of a consumption-based model. What that simply means is you pay for what you use and that's it. That's all. You don't pay for anything extra. You don't have to pay for, things that are being unused. You pay for what you use and that's it. Which kind of leads into just kind of the cost of operation. Now, this is something that you will see. This is a really important thing to kind of understand. And it's this idea behind capital expenditure and operational expenditure. So capital expenditure is what you can kind of think of when it's on premise, right? If you own servers, it's the upfront spending of money on physical infrastructure and then deducting the upfront expense over time, which is where you like amortize it, or you kind of say that like the depreciation, right? So from a company, and this is the business side, right? The CapEx is money that you have to spend up front. If you were going to buy servers, right? If you're going to not only buy the server, you have to buy the racks, right? You have to buy the cooling, you have to buy a building or rent a building that is going to house that. Then you have to buy security for that. You have to do a bunch of stuff for the upfront cost just to get a server up, right? Just to even get things going, you have to have capital expenditure. And then you have to have the subscription model that you pay for because you have some sort of something, right? You're probably not building out every bit of infrastructure, including the operating system. You're probably not doing that. You're probably not building out totally everything. So not only are you having to pay for the servers up front, which, in tech, as we see, like with the iPhones, after 5 years, 5 year ago computers are kind of obsolete compared to now, right? There's the M1 chip in the Apple is much, much better than the i3 chip that happened in the MacBook Pro years ago, right? And so you're paying for this up front, and then you're eventually going to have to increase, buy more, update, or do something like that. Versus operational expenditure, which is spending money on services and products now and being billed for them now. So it's not just this upfront cost that over time you either depreciate or you say like, okay, well, I'm going to spend 10,000 now. And then over time it's going like, I'm saving this kind of little bit, if you will, but instead it's like, no, it's just a subscription based, right? I'm actually just going to pay for now what I'm using now, but I have no upfront cost. One way to kind of look at it, I don't know if anybody has leased a car lately, but it's like buying a car versus leasing a car, right? Buying a car, you are taking out the loan, or if you pay cash, or you're putting some sort of money down, right? And you're paying upfront. I am buying this car versus leasing a car is like, it's not necessarily mine. It's not mine, but I'm just paying one fee. I'm using it now and I'm going to be billed now, but I don't have to worry about it in the future. I don't have to be, is it going to go upside down? Is it going to do something like that? I'm just paying now. And there is no upfront cost, right? You don't have to put any money down to lease a car. You just pay for the car that you're going to use and that's it. And so operational expenditure is another thing like that, right? There is no upfront cost. And as you pay for a service or product, you use it. So if I'm using this service, I'm paying for it. If I'm not using it, I'm not paying for it. I don't have to worry about amortizing that or depreciating that over time from a accounting perspective. So what does this mean with the cloud? Well, if you're using something with the cloud, it's going to lean more towards this operational expenditure, right? Because you're not paying for the servers, you're not paying for everything. You are just paying for these subscription fees, right? You're paying for Azure and the services that you're using versus capital expenditure. You are paying for everything. Now, I like this because it really makes a lot of sense, but it's kind of like an iceberg, right? Let's say we're on a boat and we see two icebergs. Right here on the one on the left looks a little bit smaller than the one on the right. And that's kind of how, OPEX versus CAPEX can look sometimes. Subscription fees might be a little bit higher than the software licensing costs, right? So just comparing just those two things, subscription fees might be the more expensive route. But if we're looking from a business perspective, software licensing costs are low, but you also, and that's the idea behind the iceberg, this iceberg is much larger than this one. And the iceberg represents the total cost, right? Because not only are you paying for the software licensing costs, but you also have this customization and implementation, right? So you have to build it out yourself. You have to build out everything. So you have to hire somebody to do that. Then you have to pay for the hardware. Then you do have to pay for IT personnel to make sure that everything is working. Then you have to pay for maintenance, right? You have to make sure, again, we talked about the building. We talked about security in your, whatever on-premise. You have to talk about if something breaks, you fix it. IT personnel have to go in, make sure the network is set up. And then you also have to train, right? You have to train people on using that different, you still have to train your employees. You still have to train developers on how your cloud or your on-premise servers work versus OPEX, right? The subscription fees might be a little bit higher, but that's all you pay for. After that, all you're doing is paying for implementation and customization. So maybe if you do have something a little bit more custom, you might add that on like a little trinket. And then maybe some training for your developers on, okay, this is how the Azure cloud is going to work. This is how, we're going to do these certain things, but that's it. You don't pay for maintenance. You don't pay for buildings. You don't pay for security. The energy cost of running servers, you don't pay for that. The cooling, you don't pay for any of that. And so this operational expenditure, as you can see from a total cost perspective, from a business side, it makes way more sense to go to the cloud. And they actually have done a study, it's like a third-party study, so it's not just Microsoft. But on average, a company moving from on-premise to the cloud, do I have any guesses on how much they actually save per year? Anybody got any good guesses? Richard, you're really close. On average per year, a company will save 75% by going to the cloud, which is a lot. Right. So from a company perspective, if they're like, hey, new developer, should we go to the cloud or not? You can sit and show all of this, right? And say, this is everything you're going to have to pay for versus, OpEx, your ongoing costs for subscription fees, training, configuration, and system administration. Versus having our own, you have to apply patches and upgrades. So you have to have somebody who's strictly just a network engineer, pay for downtime, performance tuning. You have to pay for all of this stuff. So it's a pretty simple and easy thing to look at and say, yeah, this makes sense. The cloud is kind of king for how we are going to host our applications. Somebody asked, but isn't it expensive in the long run if a company scales? Heard costly stories of AWS fees when company scales. So that would be dependent on the company, right? And you have to think about it this way. If you scale, right, like Facebook might have some sort of on-premise, right? Because in that case, right, there might be a little bit of a reason, or there's some sort of kind of security, like I want to have an internal network, so I'm going to have a server on my own. But even if you're scaling, whether you're scaling on-premise or in the cloud, you are still going to have to buy new servers. You still have to buy new networks. So now you're going to have a network, like add an additional network engineer. So I think overall, from the perspective, even if you're scaling both ways, right? You're scaling either on the cloud or you're scaling on-premise. But on-premise, unless you are utilizing 100% of the server, you're always missing out on like optimizing your server. So one really cool thing about the cloud is I can set up, how much I want to use, right? And so if I want to use an entire virtual machine, let's say I want to pay for my own server, I want this to have a dedicated server. Okay, right? I can pay for that. I won't always be using that server 24/7, right? So I'm not optimizing that server, but I can pay for that. But what the cloud can do is I can say, actually, I just want a virtual machine on the server. And maybe the server can have 5 virtual machines running at the same time, right? Because that's just the hardware that's set up. So now, instead of me paying for one server, I am paying for 1/5 of the server, right? Because out of 5, I have one of the virtual machines. And this is where, when you start kind of diving into the material, you'll look at like Kubernetes and containers, as you can even compartmentalize and say, well, actually, I just want to have not even just this virtual machine. I just want to have an application on a virtual machine. Maybe a virtual machine can have one application or 3 applications. So you're even compartmentalizing it and saying, actually, I just want a little sliver of the server because that's all I need from a company. And they go, okay, well, you're going to pay 1/32 of this server cost, right? Now, they're not going to say 1/32. They're going to, just say you're going to pay this much, but that's the kind of idea behind it. So you're paying for what you have. But if you are like scaling, and you add one more server, unless you're fully using that server, it will always be more expensive for capital expenditure versus the cloud, which is that OpEx. So great question though. Any other questions? Cool. So we just have maybe 10, 15 more minutes and then we will take a little break. I have one more thing to really talk about, take a break, and then we're going to have a group project or a group kind of activity that we can dive into. So with this cloud service, we have what we call a cloud service models because every company is different, right? A mom and pop is going to act differently than some large organization like a Spotify, right? They're going to act different. They're going to have different things. And so what we have is we have 3 different models that you can kind of pick from and move towards. The first one is going to be infrastructure as a service. This is the closest to maintaining actual physical servers, right? Being on premise. But what it is the cloud provider. So let's say Azure in this example, they will buy the hardware. They still buy, store, have security. They make sure everything's set up and up to date. But from there, other than buying the server and using the energy and all that stuff, everything else is up to you, right? You can pick whatever operating system that you want. You have to maintain that. You can pick whatever network configuration is up to you. Anything. It's like the most customizable for sure. You can set up anything you want, but the actual hardware itself, having to, again, rent a building, all of that is still on the cloud provider. So infrastructure as a service is kind of a sweet hybrid of both, right? It's like you have servers that you then can, if you wanted something from a like a networking perspective and you wanted to build it, or you had people in-house to already build it, that was already part of your system, you could do infrastructure as a service to where, okay, I don't have to pay for the servers. I don't have to pay for that hardware to be up to date and continue to like have good memory, but I can actually have as much customizable kind of opportunities as I want. That's what we call infrastructure as a service. Then there's platform as a service. Now, if you did a black belt, that's what you use, was platform as a service, which is using the cloud as your hosting environment. So let's say you have a web application. What you do is you say, I want to host it onto your server on the cloud. And so it just says, okay, great, creates a virtual machine. And then you just deploy your application onto that, and then it hosts it in the background. That's it. So platform as a service is what is really, really popular. That's kind of one of the more popular ones from a web application, right? So if you go to a company, it's going to be more of a platform as a service, unless it's a larger company, then you might have infrastructure as a service. But again, it also depends on what company you're at, right? If you are working for a company, let's say that isn't tech, right? That you're a software engineer for them, but like a friend of mine worked for a company that basically they got people out of speeding tickets, but he was a software engineer for them, right? That was their entire job, was to like fight speeding tickets, but he was their software engineer. Well, they're not a tech company, so they aren't going to have likely a like network DevOps engineer. They just have him. So, okay, we're going to use their platform. I'll build the application. I'll run it on their platform. I'll deploy it, but I don't need to do anything like that infrastructure as a service. So that's where the platform as a service can come in. The cloud tenant, what they do is they deploy the application into the hosted environment, and the provider provides the virtual machine, all the network resources. They kind of make sure everything is set up, and then you just have to deploy your application. Again, just like the black belt, deploy your application, and then it's hosted by Azure. And then the last one is software as a service. Now, this is more of your kind of mom and pop sort of store. This one is the cloud service. Cloud provider manages basically all aspects of the application environment, data storage, applications. All the cloud tenant needs to do is provide their data to the application managed by the cloud provider. You can kind of think about this as a software as a service would be something like a Squarespace or a Wix, right? So you don't actually need to, you pay for this software, and you don't have to, if you're a mom and pop, so you don't have to know anything about development. You don't have to know anything about how to build a web page. You don't have to know anything about JavaScript or CSS or HTML. You can literally just say, I want to customize and I want to make this color, this color. And I want to put an email box that my people can put their emails into. And then it's like, okay, great. Squarespace will handle data storage. They'll handle all the virtual machines. They'll handle it being hosted. They handle everything there. That's software as a service. Now, as you go from software as a service to infrastructure as a service, it does get a little bit less customizable. So here, it's just a kind of a great breakdown of what it looks like in the different kind of comparisons from the different service models. What's in blue is what the cloud provider will manage. So like Azure in this instance, this is what they will manage. And then in the green is what you or your company will actually have to manage. As you can see, on-premise is everything, which is exhausting just to even look at. But you can see that regardless of if you're infrastructure, platform, or software, the storage, the networking, and the compute, all of that is handled by the cloud providers. You don't have to do anything there. That is getting everything set up for your server, the storage aspect, and like the computing power, all that's handled. And then you can see the varying things and responsibilities you have as a user, right? If you're an infrastructure as a service, there's quite a few things, right? The virtual machine, the operating system, runtime, applications, data, and access. And then if you move on to platform, you can see that it handles runtime. Now the cloud provider manages runtime, operating system, and virtual machine. So all you have to do is put your application up on there, and then give it some sort of data if you have users that are going to input some sort of data. And then software as a service is just the data and access. Now, one thing I will say is, as you move from software as a service to infrastructure as a service, you get a little bit more customization opportunities. Software as a service, one of the downfalls is you are like, let's say Squarespace, for example, you are kind of locked into whatever that software will provide for you. And this is what happens all the time, right? Is a company will have some sort of software and they say, well, I need it to do this one thing, and it just isn't built that way, right? And then maybe they will hire some sort of company to build another application, or hire a developer to actually build out their own platform. But one of the downfalls with software as a service is you are limited to whatever is there, as long as, whatever the software has, as long as it is able to do that, then great. But if it's not able to do that, if it's not created that, you're kind of limited, right? You're confined to whatever the software will provide, versus something like an infrastructure as a services. You build it, right? You can build it and customize it to exactly what your company needs at that time. Any questions as kind of these guys? Again, this is the most heavy that will instruct. So I know that this is a lot. So thank you guys for your patience and your kindness.
Well, just quick questions. Yeah, everything what you just said is very clear and understandable. I just want to know, like, is there any way I can add, like, let's say I deploy my website, right, on Azure, and I want to add some feature or just like update this feature. Is there any way I can do that on Azure, or should I go? Oh, okay.
Yeah, so Azure, so the second part of this afternoon is we're going to talk about kind of the core services that they provide, but they're absolutely, even if it's added on, you can add on different things, right? Say like whether it's monitoring, which we're going to look at here in just a second, like I want this sort of monitoring, or I want this to be available, or I want to, there's this really cool thing called Cosmos DB that Azure has. And let's say two companies, you'll talk about it later on, but two companies, let's say Microsoft buys two companies because Microsoft owns LinkedIn and GitHub, right? Which is true. So let's say that when Microsoft bought LinkedIn and GitHub, let's say LinkedIn used a non-relational database, so something like a MongoDB. Let's say GitHub used a relational database, something like MySQL or Postgres, something like that. Well, there's actually a service. So let's say you are Microsoft and you are providing, and you're running it on Azure, and you say, I just bought these two companies. I need something. Somehow I need their data combined together. Well, there's this really cool service called Cosmos DB that basically allows you to take this non-relational database and this relational database and put them together into one and call it like an API call. So you have access to that data there. So what's really great about the cloud is there's so many tools that you can actually, as your company grows, implement different things about the cloud. And that's also where that cross cloud kind of comes in, to where maybe let's say you're on AWS and you buy two companies, right? And maybe they don't have something like Cosmos DB. You say, okay, well, great. For this portion of my organization, I'm actually going to use the Azure cloud because they have this really great service called Cosmos DB that I can utilize and add that tool and then connect the two together.
Wow, that's impressive. Thank
It's
you.
very, yeah, that's why, obviously it kind of sounds silly, but like that's why the cloud is so important, right? And so like everything's on the cloud. Every major company is on the cloud. That's why AWS and Azure and Google Cloud are like very rich and like
Right.
have such a large thing, because the cloud is in my opinion, this is why I love doing these workshops. Cloud is the future. That is what web development is. That is what web applications, anything on the web is going to be the cloud. It doesn't make any sense for it to not be.
That's hilarious. Thank you.
Yeah. Great question. Anything else? What are CDNs? We can talk about that in just a little bit, because it's not necessarily applicable now, but we can talk about that right before lunch. Just remind me there.
When it says runtime, it's just the time like the requests are coming in or the server is active versus idle. Is that what it is?
So it's more of like yeah, so like requests coming in, do you have a load balancer? So what a load balancer will be is you can kind of set it up to say, hey, let's say you have 3 servers. So here's a great example. One of our instructors worked for AWS before he came over to Coding Dojo. And what he did was they worked for the Kindle section. And so what happened is there's this thing called a load balancer where you can say, hey, I have 3 servers. And basically it's just like a director of traffic, right? And so once somebody comes in, they go, I want you to go to server 1. Another request comes in, I want you to go to server 2. Another request comes in, you can go to server 2, and then another one, go to 1, go to 3, right? And so it kind of directs traffic there. And so what happened is actually server 1 and 2 went down, right? For AWS, right? Just the server went down and they still had server 3. And so what it could do is they went in and they were able to change the load balancer to direct all traffic. They upped and increased, they scaled horizontally to increase virtual machines. And then they were able to set the load balancer and say, okay, I want you to go everything is going to go to these new virtual machines that were set up, right? And so this runtime is, okay, where is it actually going? What is it actually doing? How is it going to operate there? Great question, though.
Thank you for clarifying.
Yeah, of course. Richard asked, so deploying your belt exam on AWS was an instance of a platform as a service, correct? You can determine the operating system when setting up. Yes, AWS managed it. You just put your application. All you were in charge of as your platform as a service was the application. So your web application that you created, whether that's in Django or ASP.NET or Spring Boot or whatever, right? React or Node. And then the data. So, when you created a form, that was some sort of data. And you were able to pick the operating system. You were able to pick everything. And then all you put up was your application. So yes, exactly. When you deployed onto AWS, which I have a cool little graphic here in just a bit to talk about that. But when you deployed onto that, you use a platform as a service. Same thing on if you were to deploy on Azure, same sort of, if you have your same application, you were to put it on Azure, you're going to do the platform as a service. Yeah, of course. Any other questions for you, my friends? Cool. So we've talked a lot about the cloud, but how does this practically work? Right? I have 2 different graphics to kind of show how a company would actually implement this, how the cloud would actually really work from a company perspective, maybe like an enterprise company perspective. We have this of kind of like, where do I place the cloud? And this is just an example of your kind of experience so far. Like you got your yellow belt, then you did a Python belt, or if you did the part-time accelerated, then maybe you did like MERN or something of that different. And then kind of if you did all belts, you're kind of here with an understanding of, okay, I have a couple different languages. And then now it's, okay, so how do we, where do I place the cloud? It's kind of like your next step, right? Where you start understanding the cloud because the cloud is everywhere. And you start kind of simulating what we call a sprint or a scrum, which is like, okay, I'm going to have this set up at this point. So this is where you are launching a living project. Now, as you are understanding the cloud, I would wildly encourage you, mess around with it, put projects on the cloud, put projects on like a free instance of an AWS or an Azure, because Azure will give you 200 credits when you sign up. Put it on there so that way when a recruiter, right, if you have this application that you're proud of, when a recruiter, on your GitHub or on it'd be your LinkedIn, right? When they go onto your LinkedIn or your resume and they can click on it, if they can go and actually interact with your application, that's really, really crucial. And so that's what understanding the cloud now is, okay, I can do this monitoring. I can see how much traffic's coming. I can do a bunch of stuff. So that's kind of where we place the cloud now. Now, this is an example. If you did do the if you did do the black belt or you try to deploy, even if it wasn't a black belt, this was kind of the process, right? So here's us as developers and here's the cloud. So what we did, if you recall, is we actually did two things, right? First off, we wrote our application and then we pushed it to GitHub, right? And this is Git, but we pushed it to GitHub, which is just our version control, right? Or Git is our version control, GitHub just where we host it. And then what we did is we did this SSH key, which is where we kind of use our deployment key and got into, for the black belt, you got into your EC2 instance, which is your Amazon AWS EC2 instance, right? So you went, you picked an operating system, you kind of set up everything, you followed the platform. And then what you did is when you were on this server, it's like you're on this virtual computer, right? And so what you did is then you went to GitHub and you pulled your code from GitHub, right? You said, okay, I have this application. It's on GitHub. I'm going to go in, I'm going to grab it, and I'm going to put it on this server in the cloud. So we did that. Then we used GUnicorn and Nginx to create our ports. So that way, when somebody else wants to go and run my application, see my application, we had this IP address that they could go to, and then we could, boom, click on it, see my application. Now, one of the issues is, let's think about this. Let's say that I am making quite a few changes throughout the day, right, of my application, let's say, or throughout the week. I guess the day would be kind of crazy, but let's say I have this application and I'm making quite a few changes. Well, what I have to do is I actually have to SSH every single time, go into my server. That's my key, right? That's like kind of secret to connect to the server. Then I'd have to push the code to GitHub again, right? For every single update. Then I'd have to go and I'd have to pull the most recent code. Now for us, let's say we do it 5 times a week. Well, that's kind of a pain every single time. Might take a little bit, kind of a pain. But let's say you work for somebody like a GitHub, like a LinkedIn, to where your team might be doing some changes on this portion of the application. But maybe from an overall organization standpoint, let's say there's 6 different teams, right? And so every single time, it doesn't make sense, right? For each team, if they're doing 5 a week, to go in and then go change it, it sounds like a pain. So what would actually happen, and this is how it's set up from like an actual enterprise standpoint, is it would be something like this. And this is where the cloud comes in. It's great. Is here you have your developer. You would push your code to GitHub, right? So you would set it all up one time. Then you push your code to GitHub. And then what would happen is you have this thing that the like Azure can set up. And what it does is it waits and detects new changes. So if you officially, push your code, say, okay, I'm going to push it to production. Then what it does is it detects a new change, builds, it says, okay, great, there's a change. Something's pushed to production. It automatically will build and compile that code, right? It doesn't change what's currently in production. You just push it to production so far. You push your code. And then what it does, it builds and compiles. Then what it would do is, and this is just an example of again, when our instructor Sal was at AWS, this is how it worked, is you had 3 different kind of containers that would happen. First off, it would compile the new code, and it would go to this first container called Alpha. And what would happen is Alpha would send it to some sort of unit testing, stress test, integration test, basically say, is this code going to break if we push it for all of our users to see? And so you write, your developers would write some tests, and then it would, constantly check this specific test for this Alpha one. If it comes back and it says, nope, everything's passed, all the tests have passed, it goes on to pre-production, where it has an additional set of testing to where you can test different things, right? Have different unit tests, integration, stress tests. If that passes, then it says, okay, cool. It's passed all of our tests. Let's go ahead and push it to production. Now, once it pushes it to production, and this can all be automated and set up, right? You don't have to like go in and say, okay, now push the test. Okay, everything passed, everything's good to go. It's kind of like a one and done sort of thing. Once it gets to this production, this is like whenever we had our EC2, right? And we just had some sort of port that we could go to. Once it gets to this production standpoint, now my users can see it, right? Now my users can interact with my application in the new way that I just said that it could interact. And so now my users can see it, but then what the cloud also provides, and Azure provides this, is monitoring. So what I can do is I can sit and monitor the traffic at my application, right? And so let's say it's 3 p.m. and I am Facebook, right? And I have all of this traffic consistently. Let's say at any point, 300 million people are on Facebook. Well, if my monitoring is there, and I, let's say I look at it and only 100,000 people are on Facebook, but normally it's 300 million. Instantly, what that tells me is, oh, there might be something going on if only 100,000 people versus 3 million are on our website. Something's going on, right? It's down somewhere. People can't access our application. There is an issue happening. With monitoring, you can also set it up too, to where you can say, hey, if the threshold ever hits, let's say it's normally 300 million. If the threshold ever hits 200 million, I need you to let me know. Send me an email, send me an alert saying, hey, only, this monitoring thing is hit. Then we go, okay, great. Let me go in and look at it before, it goes down to 100,000. And so from an enterprise perspective, this is how the cloud would actually go, right? So we just talked about the cloud, and this is how we'd implement this. We'd have some sort of infrastructure as a service or platform as a service, and we would have this new change detected. We'd have these unit stress tests, and then we would push it to this Azure virtual machine at the end of the day. And then Azure would have some sort of monitoring that as this code is gone, we have monitoring going, and maybe some fail safe that, okay, if only 200 million people are viewing it, I need you to send an email to this people that's forwarded to this people. And then my developers can go and my network engineers can go instantly and go look and say, what's going on? Oh, a server's down. Let me move it over and let me do some sort of kind of manipulation of that. Like we talked about with that AWS. I can manipulate and use the load balancer to kind of set it up until, we fix whatever's going on because, oh, this person pushed this thing and it actually ended up breaking it, something like that. Somebody asked, are there different versions of Facebook instances running on a virtual machine when people are viewing it? So what you can actually do is you can set, well, yes, there would be different versions of Facebook instances running, only because you're right, there might be some different legal things wherever you're at locally or geographically. But what it would be is you wouldn't just have one virtual machine, you would have a group, right? You would have an entire group of virtual machines that are handling with a load balancer saying, let's say you have, with 200 million, you would have probably an entire data center, but you would have, let's say, whatever the capacity is of like 15 virtual machines on this one server, but I'm going to have 500 servers that have 15. And so it's monitoring all of those machines. And then you can set it up to where it's like, I want, a cumulative number of those there. So it wouldn't just be on one server for 200 million. It couldn't handle that sort of request, but you would have the same application on different instances of your virtual machine, if that makes sense. That's kind of like what we were talking about scaling horizontally, right? You can take, copy, paste, and put it on another virtual machine or another server to where it's, can handle now anything. And then your load balancer will send it to specific servers or to specific instances. Great question though. Cool. Any other questions?
Oh, just to confirm. So, like you said, on Azure, we could create like unit testing, integration testing before throwing the product to the market, right? So,
yes, you would create tests. Now these are created, right?
Right.
Yeah.
Okay.
That's that test-driven development. I think there's a portion in Python that talks about test-driven development, but that's a big thing about actually generating tests, not only writing the code, but okay, can I generate tests to can I create tests that are actually good that will prevent, because like that will prevent our entire server from going down, right? Because you're really as only good as your tests are created. If you just create dumb tests, right? Then all of a sudden your application doesn't work because it passed your test, but your test was literally nothing. So.
Awesome. Thank you.
Yeah.
So I just wanted to continue from the question earlier, Will, about which would be the single source of truth when you have a real-time app or a platform. I mean, Facebook is too big, but say there's two-way interaction happening. Where does the two-way interaction from the data coming from the client side sit? if there are different instances running on different virtual machines. Say it's a chat application, or you know what I mean, like a stock application.
Yeah. So that's a great question. So one thing to kind of note is once this happens, right? So let's say this unit test passes, right? It passes and then it comes here and it pushes to production. Production is not just, okay, I'm going to go to this one machine. And then if I need to, if I need to copy it, I can. What it would actually set up is once it gets to production, let's say we talked about 15 virtual machines, right? We have them all here, whatever. I'm just gonna do 5. Well, I'm gonna keep going. Once it hits this production, we can have it set up that once this part is hit, it sends them all like instantaneously. It sends it all the same code, right? So it can just push it out there. And then my database that's set up, you would just set up this application that is connected to either MySQL or some sort of relational and non-relational database, to where now anytime these are all connected to my database. So anytime my user interacts, the database connected to this virtual machine is this one. Database connected to this one is this one. And so once it hits this production, it's not just there's one single sort of truth and you're copying it. It's instantly going and pushing all the code to all of your servers or virtual machines. That makes sense?
Got it. Yeah, makes sense. Thank you.
Great question. Really great question. Cool. Any other questions? I know we talked a lot. That was the heaviest. You guys have done it. I'm done talking for right now. Is there any other questions?
Simple question, very simple. How many apps can you run on a free tier? Like when you coding Dojo, you would deploy an app. How many simple apps can you run on the free tier?
On the free tier? Great question. I don't know the answer to that. I can look into it. I know that Microsoft gives you 200 credit, or I think 200 credits for the first 30 days of setting up. But I don't know exactly how many applications, because it kind of varies. There's also sandboxes that Microsoft allows you to play with. But I don't know exactly.
I was asking because if you want to have several apps you want to show to employees, just because they're deployed on AWS or wherever you deploy it at, how would you do that?
Yeah, great question. A couple of ways, right? So one thing you could do is you could actually, and I would encourage, right? If you have the entire platform for Coding Dojo that shows you how to do AWS, put one free one on there. Right now, I wouldn't say you don't need 8 things deployed.
Maybe just a couple or two or 3. That's what I'm saying.
Exactly. So there's different things you could do, right? So you could do one in AWS, which actually shows like, hey, not only do I know this, but I also know AWS, right? So have one in AWS, one in Azure, one in Google Cloud, maybe all 3, to show like I can deploy any of them, which I think would be great. There's also different things you can do. There's one called Heroku, which is a way that you can, it's more of like a platform as a service that you can just host an application. That's really all it's designed for. It's not this cloud per se, but you can host an application on Heroku. GitHub Pages is another one that allows you to actually your GitHub code. You can use GitHub Pages and say, well, just take this code that I just pushed and I want you to run it and host it, which in theory, I guess is on Azure because GitHub is owned by Microsoft. So if you wanted to do that, there's different ways like Heroku, GitHub Pages are like free, low cost, if anything, ways to do that versus using something like an AWS. And this is just from a company, you would never put right on Heroku or GitHub Pages. You wouldn't put your company's application on there, but just to show your application to recruiters or people that are interviewing, then you could do Heroku or GitHub Pages if you chose not to do AWS or Azure or Google Cloud.
Okay, thank you. I wanted to know. That's what I wanted to know. Okay, thank you.
Yeah, of course. Oh, anything else, my friends? Well, all right. We are going to have we'll do a 20-minute break. So we will come back, or 19-minute break. So we will actually come back here at 10:45. So I'm going to pause the recording.